microcontroller. Today we will see 8051 microcontroller architecture, which is an 8-bit microcontroller manufactured using N-channel MOSFET field effect transistor or else CMOS complementary metal oxide field effect transistor in a variety of packages. So it's a 8051 uh, is a microcontroller which is a generic microcontroller. The range of microcontrollers, few microcontrollers may be having more ROM, more RAM, and a few microcontrollers may be having more timers, less timers. So that depends on your application and the requirement. So the microcontrollers ranging from numbers ranging from 8031 to 8751. 8751 actually include a whole family of microcontrollers. They belongs to a family called as 8051, a microcontroller family, MCS 51 family. Okay. So now the one which we are discussing is an 8051 microcontroller, which is a DIP microcontroller having 40 pins. You can see here, these are 8 pins. These are next 8 pins. These are next 8 pins, and these are next 8 pins. So these pins are port 1 pins, port 3 pins, port 2 pins, port 0 pins, and few other pins. So 40 pin IC this is. 20 pins will be there in the left side, 20 pins will be there in the right side. So which is a DIP IC. So we will see the detailed discussion of details about each and every pin and the remaining things in the coming slides. So let us start the discussion with the specific features. So 8051 is a 8051 is a 8-bit microcontroller. It's an 8-bit microcontroller and with registers A and B. It is having a 16-bit program counter and data pointer, and it comes with 8-bit stack pointer and program status word. And it comes with 4 kilobytes of internal ROM. The one what we are discussing is the one that we are discussing is 8051 microcontroller with 4 kilobytes of ROM. Few versions may not be having this much ROM. 0 kilobytes RAM also will be there, or 8 kilobytes ROM also will be there. But the one we are discussing is considering is having 4 kilobytes of internal ROM. So 128 bytes of internal RAM, which is divided into 3 parts, and 4 IO ports. 4 IO ports like P0, P1, P2, P3 in order to communicate with the outside world, to take the data, to send the data outside. So we use these ports, and 16-bit timers are counters. These two circuits like T0 and T1 are the timers are counters. We know what is meant by a counter. Counter is one which counts the number of clock pulses arrived at its inside. Timer is one which generates the timing signals. Okay, and full duple serial data transceiver, serial communication. Serial communication section will be there in this particular microcontroller. All these are embedded inside this microcontroller, are available inside the microcontroller readily for the user to use for their applications. And a few control registers will be there, mode selection registers will be there, 2 external and 3 internal interrupt sources will be there. And apart from all these sort of things, oscillator and clock circuitry, which is very important to make the microcontroller work efficiently. So the clock is a very important signal which should be supplied to the microcontroller. The range of clock frequencies that you can apply is from 1 megahertz to 16 megahertz. Typically, we consider a clock frequency of 11.0592 megahertz to this microcontroller. So these are the features. All these features of the computer are best learned by an internal hardware design. So we are going to see a hardware design at the block diagram. So with the help of that particular block diagram, we are going to understand the features of this particular circuitry or this particular microcontroller. So that is what is called as the architecture of architectural block diagram of 8051. So this is what is the architectural block diagram of 8051. So let me read out the names of these blocks. So this block is arithmetic and logic unit, which performs arithmetic and logical operations. And this is A and B. A and B registers are 8-bit registers. So these are used to store the data temporarily for any arithmetic logical operations. Okay, so and program counter is one which maintains the sequence of the program, data pointer register. These two registers are 16-bit registers. And program status word is nothing but a flag register which is an 8-bit register. So once again, arithmetic and logic unit performs the arithmetical and logical operations. A and B are two general purpose registers used for arithmetical and logical operations. Program counter and data pointer, these two are 16-bit register. Program counter is one which is used to maintain the sequence of the program in the execution of the program. Data pointer, if you want to access the data available in the external devices, external memory, then we use this data pointer. Data pointer higher, data pointer lower. Program status word, program status word is nothing but the flag register. And coming to this, at this block, this is a special function register and RAM block. Okay, so there are certain registers which are dedicated for certain very specific functions. So those are special function registers. RAM. So microcontroller comes with certain amount of RAM. This 8051, the one we are discussing, comes with 128 bytes of RAM. So we see the details of what is this RAM, what are the various divisions available in this in the next video. And ROM, read-only memory, and these are the ports. Okay, port 0, port 1, port 2, and port 3. So using these ports, we can send the data to the outside world. We can take the data into the microcontroller, and all these are the connecting things are lines are the buses. Bus is a group of wires. That bus may be a 16-bit address bus. That bus may be a 8-bit data bus. You may be taking the data from a device into the microcontroller. You may be sending the data from microcontroller onto a device. So that data will go through this or come into the microcontroller through this data bus. Okay, so let us see the detailed discussion or points related to each and every block. Coming to the register, registers are used to store the information temporarily. Just like a rough notebook, if you want to store some numbers, you need somebody is telling you the contact number, which is very important for you. You want to note down, so you need a place to note down. So that is like a register, rough note like a register, a notepad like a register. While the information could be a byte or else data to be processed or an address pointing to the data to be fetched. So data means the data may be a number, that number may be an address of a location, that location may be having the data. So that data will be stored in this registers. The vast majority of 8051 registers are 8-bit registers, like A accumulator for all arithmetic and logical operations, B R0, R1, R2, R3, R4, R5, R6, and R7. All these are the registers. All these are registers. R0 to R7 are general purpose registers. A and B also are registers. Data pointer, as I told you, data pointer, we use it for external access. External access. Program counter is used to maintain the sequence of the program. So the program counter is a 16-bit wide register the program counter points to the address of the next instruction to be executed. So these are the important points. And the next point is program counter is the only 16-bit register that will not have any internal address. Remaining all the registers, you can refer to them with their address or with their name. But program counter is the only register that does not have any internal address. The moment you switch on the microcontroller, the microcontroller starts executing the program from 0000 location onwards. And coming to the data pointer can be accessed into two registers. One is DPH, data pointer higher, data pointer lower. You can't data point DPTR does not have a single internal address. This DPTR will not have a single internal address. You can address to this particular, you can use this particular DPTR, okay, higher separately and lower separately. Okay, so higher register will have one unique address, lower register will have one unique address. The main purpose of this data pointer register is to access the content available in external RAM or else in external ROM. Okay, clock circuitry. Clock is just like a heart of the microcontroller. So which generates the clock pulses by which all the internal operations are synchronized. Synchronized. Pins XTAL1. As I told you in the beginning that 8051 is a 40 pin IC, dual inline package IC. Two pins are dedicated for clock signal. So XTAL1 and XTAL2. They are provided for connecting the resonant network and quartz crystal oscillator we use preferably to supply a high quality clock signal to the microcontroller. If the clock frequency is not divisible without a reminder, then the resulting communication frequency is not called standard frequency. The CPU is executing an instruction and takes certain number of clock cycles. So these are referred to as machine cycles. So now let us suppose this is the clock signal. This is clock signal 1, clock signal 2, clock signal 3, 4, 5, 6, like that. Okay, so a group of 6 cycles is what is called as one machine cycles. We use this concept in the calculation of time delay. In the time delay. Okay, so and eight and the clock frequency that we use, is 11.0592 megahertz. Though it is sounding odd, as it is a standard frequency, we will consider that particular frequency. That particular frequency only will be applied to the microcontroller. Okay, so with this, I'll conclude this. We will see the explanation of the remaining blocks in the next video. Thank you.